Without further ado, would love to really welcome our speaker for tonight. He is a product leader with over 17 years of experience, and he's the founder of TechProductManagement. I'm really excited. He's a great speaker. He's an instructor at Stanford, and so you guys are really lucky to be here tonight, and we're lucky to have him. So without further ado, let's give it up for Daniel.
Thank you so much, Sam. Thank you for such a nice introduction. Thanks everybody for being here. Is this going to be okay?
Yeah.
I'm a little self-conscious about it now. Okay, great. So, let's see. That's the way. Perfect. So, you have more slides coming here, Sam?
Oh, that's for the end.
Okay. Okay. Then.
Those are all for them. That's okay. You just keep going. Yeah.
Okay, perfect. Okay, so thank you for being here. Again, my name is Daniel Elizalde. I'm going to talk about product management for the Internet of Things today. A little bit of my background, Sam mentioned, I've been in product for about 17 or 18 years doing connected products. So my whole career has been about connecting things to the Internet. Every time you think about something that is hardware and connects to the Internet, that's the kind of work that I've been doing before it was cool, before it had names like IoT. I started my career as an engineer, doing software development, embedded development, and then I've gone through many roles in terms of career progression from consulting to management to executive positions. My last role, I was head of product for a company doing IoT solutions for the smart grid, and about a year ago, I decided to start my own practice. So I help companies develop their IoT product strategy, and I help them by training their product teams either online as an advisor to companies, and I also teach at Stanford Continuing Studies. I teach product management for the Internet of Things. I'll talk more about that in a minute. So what I want to share with you today is a little bit of the work that I've been doing and convince you that IoT is something that is not necessarily something that I invite you to join. It's something that is inevitable. That's where the technology is going, and it poses big challenges for product managers because it is very hard. And so we need to get ready as a profession to be able to capitalize on that wave at the same time not being obsoleted. So I'll tell you a little bit about that. I want to start by this quote from Marc Benioff, the CEO of Salesforce, and he said, "The Internet of Things is ground zero for a new phase of global transformation, powered by technology innovation, generating significant economic opportunities and reshaping industries." So we're seeing this in all different areas of industries, all different types of products from consumer, enterprise, industrial, etc. We are seeing products that you might be familiar with, like the Nest, and not a lot of people know that not only a connected device, but it's actually provides a resource for utilities to be controlled and reduce the energy consumption of houses through the Internet, right? So those are more advanced ways of managing the Internet of Things. We're seeing big applications in robotics, in manufacturing, in autonomous vehicles. There's this very interesting application, this company called Cherry Water. It's an organization that provides water wells for communities in need. And they implemented an Internet of Things solution on the wells to determine when the well is going to fail. And that way, they can do predictive maintenance on it, and they can reduce the time that the well is off from 3 months to just hours, right? By having all this analytics and this expertise, they're able to have a significant impact. And I bring these examples in critical infrastructure, energy, automation, healthcare, because I believe that oftentimes the Internet of Things gets a bad reputation because we only see in the media a lot of the devices that are the toaster connected to the washing machine, connected to the coffee maker, which are cool and all, but they're not that impactful as you could be with a lot of these applications that we're seeing that are live today and that are providing a lot of value around the world. And it's exactly the same technology, and it's exactly the same PM approach. That's what I want to bring to your attention. A lot of applications in transportation, from jet engines to automotives to trains, ships, trailers, all that is the same approach. By the way, just to get to know you, if you have questions, please, let's make this interactive. Sam asked, how many of you are PMs today? Okay. Yeah, just as a profession, right?
As a profession.
Yes, okay, a few of you. how many of you have a background of, let's say, engineering, a technical background? Okay, how about marketing? Okay, how about design? Design, how about data science? Sure, you can count it. How about just business in general, sales, management, administration? Okay, so that's an interesting thing, is because I asked that because product managers come from every walks of life. We all come from different approaches, and we all are needed in order to make the companies thrive. And so that's why I always like to know my audience. So I'll make sure that I point examples on how it affects each one of your professions and how it all comes together in PM. Now, a lot of people ask me, so which companies are doing this? And the list is huge, right? The list is huge. This is, of course, a very, very small subset, but I wanted to show you that it goes through the complete stack of technology, companies big and small. You have companies from chip manufacturers to complete end-to-end stack manufacturers like Samsung. You have industrial companies like Bosch, or computer companies like Dell, Amazon, Siemens, GE, Google, Apple, Microsoft. They're all invested billions and billions of dollars in this trend of the Internet of Things. So what that means to us as a profession is that for those investments, they require engineering, requiring data scientists, and of course it requires PMs. A lot of these companies might not advertise themselves as IoT companies, but what they're doing is investing in this trend, right? And we need to be ready to capitalize on that. On the far side, you can see that I have a lot of the consulting companies, some of the biggest consulting companies in the world. And all of them, if you look them up, they have an Internet of Things practice. Accenture, McKinsey, Deloitte, Bain, all of those, because they're seeing the need that their customers want help with the Internet of Things, and so they're capitalizing on that trend and getting into that, right? So there's a lot of opportunities for us PMs as well. And then, of course, there's all sorts of applications that, like I mentioned before, from consumer electronics to smart homes to industry to agriculture, etc. In fact, my prediction is that within 5 to 10 years, most products are going to be connected. We're seeing those trends already with a study that Cisco did recently, that they said from all the different companies that they interviewed across all industries, 60 to 65% of those companies have IoT initiatives, right? So it's already in motion.
When you say products, you mean finished product or components?
Everything. So my next question, what is an IoT product, right? So there's all sorts of different things. There's companies that are focusing just on the components. There's companies that are focusing on the end-to-end. The survey was just in general, do you have some sort of initiative, right? So I would just want to, just for the sake of this presentation, I want to talk about what the definition of an IoT product is from my perspective. This is a very product-specific definition, and there's really no consolidated definition across industry, and that's what makes it a little bit fuzzy. So I want to offer this definition so that we can continue talking about the same thing at least. I believe that an IoT product, it's a product that combines hardware and software, measures real-world signals, and connects to the internet to provide value to the customer. And I've highlighted in red some of the points that I'd like to elaborate a little bit on. So the first thing that makes IoT products challenging from a PM perspective is that it's a combination of hardware and software. So most of us either have experience with hardware or with software, but very few get the opportunity to do end-to-end, right? So that becomes a challenge. And that also translates to the companies. Very few companies have end-to-end experience. They're either hardware companies or software companies. So that merger is hard. One of the characteristics of IoT, of course, is that you measure real-world signals. So you add sensors so that you can measure your environment so that with that information you can do something, right? Connects to the internet, of course. And the key thing is that it provides value to a customer. The way I think about IoT product management, it's that it's a specialization on top of product management. So the goal is the same. The goal is for us to build products that solve customer needs and provide profitability to our companies. It just has these different flavors and different complexities, right? So it's product management first, IoT second. Now let me show you how this applies in a real-world example. I'm going to talk about a wind turbine and this term of predictive maintenance. How many of you have heard about predictive maintenance? It's like a buzzword. Everybody's talking about those kind of things. It's one of the biggest trends in industrial IoT. And so a little bit of a background, what does that mean? Since there have been motors and machinery, people have to provide maintenance to those equipments. That's not a new problem, right? So IoT doesn't create new problems. It actually provides a better way to solve them. So the problem is there to perform maintenance. Historically, the first approach is, well, we'll provide maintenance when it breaks. So when the turbine breaks, we'll provide maintenance. But the thing is that, well, at that point it's too late, because there's a big gap in between when something breaks and you call service and they bring the parts, and imagine these things in the middle of the ocean. It's going to be hard. So this didn't work. The next evolution was to come into a fixed schedule. So we can say every 6 months we're going to service the turbines whether they need it or not. And this improved some aspect, but it wasn't perfect, because sometimes you were servicing turbines that didn't need it, or sometimes they break in the middle of the cycle, so you're back into the same problem. So the next iteration of this idea of predictive maintenance is, what if we could provide maintenance only when needed? And it's a similar concept with object-oriented programming, if you may, right? What if the turbine itself could tell us that it needs maintenance, is responsible for monitoring its own status and have the analytics and the intelligence to do that, and call service, order its own parts, and be able to get serviced, right? Now, because we can actually add all the necessary sensors and the intelligence throughout the whole system, we can actually do that, right? This is a concept that we're taking from software, and now we are applying it to physical things. And so that is the idea of predictive maintenance, adding the smarts to something so that it can provide itself maintenance, not itself, but like call to be maintained, right? So what does this look like from a technology and an implementation perspective? So there are 5 building blocks here that make this possible. So first, we're going to need some hardware that has sensors that's going to acquire data from the physical device. And I call that the device hardware. That's the thing that implements the smarts on the hardware itself. Then you're going to need device software, which is the software that runs inside this hardware. And it's going to be doing the data acquisition, and it's going to do analytics at the edge, and it's going to be doing some processing and logging and things like that. Then you break that and send that data somewhere. And so you're going to have a communications layer. And it could be anywhere from from Wi-Fi to Bluetooth to LG to LT, LoRa, Sigfox, etc., depending on the application. And then all the data goes to the cloud. And the cloud really is the infrastructure that provides a way to ingest data, store data, process data at scale. And then on top of that, you have cloud applications. And these are the applications that your user is going to interact with in order to extract a lot of the value. And of course, this is a simplification, but it turns out that every IoT product, regardless if it's a consumer product, an industrial product, enterprise, has these 5 building blocks. And so with this, we can start breaking the PM process for IoT a little bit into manageable pieces. Now we have 5 pieces to look at. But now you can start seeing the challenge. How many of you work with, let's say, mobile applications? Right? It's about half, right? So you know how hard that is to begin with. And then that is only referring to the part of the cloud application and some of the cloud platform. All of a sudden, you add 3 more layers, and it becomes way more complicated. And also, you have hardware layers, which is a different process, a different timetable, a different type of team, a different cost structure, etc. So all of a sudden, this becomes way more complex. Okay? Now, although I'm talking about the technical building blocks, this is just a representation for us to understand, like, what am I talking about? But the key that I want to extract out of this is that from a product management perspective, people don't buy IoT. They buy a solution to a problem. So they don't care whether you have sensors or whether you have this hardware or whether you have this OTA software, etc. Right? The customer has a problem and they need a solution, and that's where PM comes in. We need to be able to abstract that and be able to provide value. So in that sense, from a product management perspective, IoT is just another tool that we can use to provide value to our customers, provide better, faster, cheaper solutions. But that's all it is. It's a tool. It's not a silver bullet. It's not going to end, world hunger as much as we would like to, right? Because it's just a tool in our toolshed. And sometimes it's the right tool, sometimes it's not. Right? Sometimes I advise companies that, you really don't need to go this route, right? So I think if you take nothing else out of my presentation, I would like to leave you with this, right? PM for IoT, it's a specialization on top of PM, but it really is not going to make the value proposition of a product on its own. If it doesn't add value, then it doesn't matter. Right? In fact, a lot of companies are actually struggling with this aspect. In this same survey that I mentioned from Cisco, they mentioned that 26% of the companies had some success with their IoT initiatives. So if you flip it around, 74% of the companies are not being successful. They're not meeting their goals. They're not even finishing the products. They're not seeing the ROI. And what was interesting is that one of the main challenges was just the people skills. They didn't have the understanding of what it takes to create a product. And so they really felt like this. A lot of the companies that I work with, and I've trained hundreds and hundreds of product people around the world, the challenge is really to come up with a good strategy that determines how are you going to solve the problem by using this approach, and then how do you carry that on through your organization and through the product lifecycle. That product strategy becomes really, really complex if companies don't have the right tools or the right people. And that's where I think product management plays a key role, right? I think we should be able to help with that a lot. Okay? Questions so far? So far, so good? Do you have a question?
I have a question, but I don't know if I should ask now or later.
Why don't we keep the questions for the last if you are not sure, right? Okay.
Because I don't know if you will cover it.
Okay, sounds good. Okay, so keep that in mind. I'll come back to you. I want to talk a little bit about the product lifecycle. And this lifecycle exists for any type of product. It's not IoT specific. This is independent of the development process, right? Whether you're using Lean or Agile or Kanban or Water, Scrum or whatever, it doesn't matter, right? These steps exist from a strategic perspective for any product. And I want to talk about how that is a little bit different and tricky with IoT. So the first step is ideation and research. So understanding the market, understanding your customers' problems so that you can actually figure out if you have the ability based on your company's core competencies to provide a solution. Right? This is usually led by the product marketing team, supported by the product management team and the executive team. Then we go into product strategy. So this is where, based on that problem and that segmentation of market, then product management takes the lead and we figure out what product can fit the needs of our customer and how we're going to go about doing that. So you have things here like defining the specific target audience, the problem statement, your value proposition, your business models, and all the different trade-offs that we have to do throughout the life cycle of our product. This is, core product leadership. Then once you have that strategy, it comes to the roadmap and product planning. So now you know where you need to go. Now let's put a plan together. That's where the roadmap comes into play. That's where defining an MVP, prioritizing all the different features, prioritizing your personas, cost analysis, build versus buy analysis. All that happens here. And usually this is led, of course, by product management together with UX and with support from marketing and engineering, data science, of course. Then we have development. And this is where you go in the traditional development process. This is led by engineering, supported by product management. And here, the interesting part is that with IoT, you have hardware engineering, you have embedded engineering, you have networking engineering, then you have communications engineering, cloud engineering, infrastructure engineering, and then whatever type of mobile or front ends you want, right? So it's kind of complex, and figuring out how it all fits together, that's challenging as well. And then last but not least, you have release planning. Some companies call it go-to-market. This is led by marketing, supported by product management, figuring out how you're going to go to market, your sales enablement plan, your operations plan, support plan, customer success plan, all that. So pretty standard. This is kind of what we do as PMs, right? Yes? No? Maybe? Okay. Yes, thank you. Where I've seen some of the challenges are in that area, and that has to do a lot with the state of the IoT industry as a whole. It's fairly new, so we're still struggling with that product strategy, definition area, making sure that we provide the right value, have the right plans. And it turns out that doing that part is kind of difficult because there's too many moving parts, too many components. And so this is the part that I focus on the most in my advising and teaching. This is where I developed the IoT Decision Framework to capture a lot of the decisions that you need to make and provide some structured approach to it. So basically that's what it is, provides a structured approach to creating a strong, cohesive product strategy. And I'd like to share that framework with you so that you can apply it and just observe how all the pieces fit together. Because that part of the challenge is just understanding what are the pieces and how they fit together. The rest is just standard PM work that is a lot of what you guys teach here at Product School. So let's talk about what that means. The framework has two parts. The first part has these 5 building blocks that I mentioned before. This exists in any application, and I call it the IoT technology stack. So we have device hardware, device software, communications, cloud platform, and cloud applications. And then we have decision areas. These are the decisions that product managers will have to make throughout the life cycle of the product in all these different areas. And the areas that I've identified are UX, data, business, technology, security, and standards and regulations. So I'm going to walk you through what that means so you can understand how all the pieces fit together. So the first decision area is the UX decision area. And by UX, I really mean understanding your users and their needs. It's not aesthetics, it's not front end, right? It's really the practice of user research. And the way I think about this is understanding who are your users, both internal and external, and what are their needs across the IoT technology stack. So you can ask the question, who are my users at my device hardware level, device software level, communications, cloud platform, and applications level? That might seem a little bit overkill for small applications, smart home kind of things. But when you go into industrial, oftentimes the people interacting with your hardware is different than people interacting with your software, different to interacting your applications and your cloud. And so all of a sudden you have an explosion of personas that you have to prioritize, and you have to make sure that you understand how are you going to solve their specific problems throughout the stack. Okay? So once you have the understanding of who your users are and what are their needs, the next decision area is data. And the focus here is to understand what data needs to flow throughout the IoT technology stack. So what data needs to be acquired by my hardware? What data needs to be processed, stored, analyzed at the device software level? What data needs to be transferred to the cloud? How often? How much? What commands do I need to receive back from the cloud? In the cloud platform, how are you going to analyze, store your data? What APIs are you going to open to expose cloud-to-cloud communication, etc.? And then, of course, in cloud applications, what data are you going to show to your users? What makes sense to solve their needs at that point? So once you have that idea of what data you need, then we can jump into the business. And here is where you're going to analyze whether your application has opportunity to provide you some return on investment. It's not automatic, right? So here in the business decision area, the questions that you're asking are, how will you monetize your solution as a whole? Or how will you monetize each layer of the IoT technology stack? Are you going to charge for the hardware? Are you going to charge for the device software updates? Are you going to charge for bandwidth and communication? It's all going to be one package. Are you going to give the solution away for free in order to provide services, and that's how you make money, right? Those kind of decisions are what you have to make here. And also calculate costs, right? What is the unit cost of deploying a new device in the field from a hardware, licensing, networking, etc. And of course, build versus buy. This is one of the biggest pitfalls in IoT today. A lot of companies going into IoT, they think that they need to build the whole stack themselves. And it's very expensive and it's very complicated. So having PM lead in those build versus buy decisions, focusing on what are your core competencies, and say, if you are a software powerhouse and you've never done hardware, this is not the right time to start dealing with hardware, right? And vice versa. If you're a hardware company and you want to just get into software, it doesn't work like that, right? And so those are the trade-offs, and you need to figure out how do you approach it. Do you partner? Do you outsource, etc., right? Yes?
Could you give some examples of what types of capabilities IoT devices could cause you to build versus buy? You may not be able to buy it or
yeah, so that's a good question. So what kind of capabilities will go into that build versus buy decision? And I think more than capabilities, it has to do with your core competencies of your company. So if, for example, you come from a cloud background and analytics background, then going into hardware and having to build the skills, the expertise, the labs, the tooling, the supply chain, is not only going to be hard and expensive, it doesn't add any value ultimately, right? So that's where you can partner or outsource with a hardware company, and then together you offer your solution as one to your customer. They don't have to know, but you're helping in that decision, right? And those are the kind of discussions that PM can lead and negotiate and help with that.
Are there costs around specific labor, like expertise or roles that are in scarce but in high demand in this kind of a framework?
Yes. So I'm going to take your question in two parts. So you were asking, are there any costs that are scarce within this framework, especially for labor? When I talk about cost here, I'm talking about the cost of deploying one more unit. So it's variable cost. It's not fixed cost. But to answer the question, the other part of the question, which labor is scarce? Data science, PM, hardware engineering. Right? Those are the areas that people are struggling the more. So.
All this information about the decision areas, which you think is the most difficult point to get an access to? Because the problem is most things, as you said, someone can have data, someone can have hardware, someone has this, and you have to collect. But to get the whole IoT, you need the whole flow. And where you think is the most difficult information which is lacking for an IoT community?
Yeah, so if I get your question, where's the most difficult part to get for companies throughout this? I think there's no one point. I think what companies struggle the most is understanding the big picture, that they need to think about all these things. And then once they're able to understand that this is all that it takes to do an IoT product, then they can apply normal business processes and PM processes to define what are their core competencies and how to approach it. The part where people are struggling right now is that they just don't know how deep the rabbit hole goes, kind of thing.
For example, I also work for IoT back in when I was working and moved to States because of my personal reasons. But the biggest problem for us was to get the customer data, because we provided IT solution, but no one wants to give us, because we were an enterprise resource solution and we wanted to give them the best cost, but they don't want to hand over the cost because they were worried that we would hand over this to the other customer. And this is a big problem for a product manager, in my point of view, to convince them to get the data, and it was almost very difficult. None almost gave us the cost. Yeah, I think that's a really interesting point about how difficult some things can be. I mean, I've talked to a lot of different companies and they all have different pain points in different areas. And the data one is really interesting. And I think that as a product manager, if you're trying to convince a company to do that, the customer, that's going to be almost impossible, right? I think that's where we have to look internally, and we have to work with legal, and we have to work with sales, and we have to work with business development to change our model and make sure that it's something that is amiable to our users ultimately, right? Because if we get into that resistance, then maybe the model is not right. So we need to, shift a little bit, right? And it's more easy to get maybe data in States because the culture is based on giving data and getting the technology. But I worked in Europe, and it's so difficult to get data because almost none want to give you the data.
Yeah, it's true. And
they are so scared. They're even scared to put something in Google Drive. They're even scared to put something in Dropbox. Oh, it's my data. I can't give any access. But when I here. The culture is so different. Everyone wants to put on the cloud.
Yeah, which is not necessarily a good thing, right? Now we're seeing some of the downfalls of just putting everything and sharing it and the lack of security, so that's a problem. But yeah, so different countries have different rules and different legislations and different things. And that's why I actually have a standards and regulations rule. So I'll get to that and I'll cover that a little bit. So hold that thought. So, but thank you for that question. Okay, so moving on to the business. The next decision area is the technology decision area. And notice that I purposefully say, first thing we do is understand our users and their needs, then figure out what the data is going to be flowing through our stack, then figuring out the business case, if we have a business case. And then once we have that, then we can talk about what technology we're going to use to solve that problem. One of the challenges is a lot of companies lead with technology and they say, we have this gadget. Can you build a business model around it? What problem does this gadget solve? And at that point, it's a little bit too late, right? So that's why the framework is designed in this way. Figuring out your needs and then your business cases and then the technology part. So here the idea is the same, right? What technology do we need to implement this solution at the device hardware level, device software level, cloud platforms, etc. But now you have some boundaries of cost, you have some boundaries of profit margins that you want, you understand your users, you understand all your different personas, so you can work and partner with engineering in a more solid way. Because now you're in a position to give better direction and share that. It's a shared role, right? The next decision area is security. And although it's more at the bottom of the framework, in general, you should be able to go through the whole framework with your team fairly quickly in a couple of days once you're familiar with it. So it doesn't mean that it's an afterthought. It means that you can't really complete your strategy until you consider the implications of security. And the idea is the same. How will you secure your device hardware? What's the worst that could happen if your device software is compromised? Your networking, your cloud software. And then you have to do good old risk analysis and risk mitigation and figure out how you roadmap those items, and off you go. But at least you thought about it. You've done the correct penetration testing. You've done integration testing throughout. There's all these techniques that I teach in some of my other classes. But the key takeaway here is that you're thinking about it from the very, very beginning. It's not an afterthought. You're not trying to bolt security after the fact. It's part of your strategy. And then last but not least is standards and regulations. So what regulations are going to be affecting your product? Different countries have different regulations. Different industries have different regulations, right? If you are, anybody works in healthcare, energy, military, right? So you know that all those have very different and complex regulations. And unless your product complies with that, you have no product. But now you have to worry about more layers. There are different regulations at the hardware level, at the device level, at the communications level, and so on. Right? So thinking about those and having them as part of your strategy, that's going to be the glue. And then, of course, yeah.
So I like your model here, and I like the way you've laid this out. Where do things like operationalizing come into this? Is it part of each of those? And then for each of these components, obsolescence. How does that fit into this model? Yeah,
very good question. So the first question is operationalizing your product. And this is outside of this model because remember on the life cycle, I am focusing more on the strategy portion. And so this would be the launch, and then you have the actual execution of life cycle, and that's the next course I'm working on, right? But there's a lot there, especially with IoT. One of the big things with IoT, as you know, is that it provides you a connection 24/7 to your customer. And so it lends very well to a software as a service type of model. And that has big operational implications when companies are going from a traditional one-off sale to as a service model. So IoT lends itself very well. Everybody's going that direction, but then figuring out how that affects operations, that's huge, right? So, and it's an excellent question. We can talk more about it if you want at the break.
So the obsolescence, I don't think you.
No, I haven't. A good point. Here, when you do the analysis on what technology you need for this, you have to have those discussions with your team, right? How do you prevent against obsolescence? How do you make sure that your supply chain is going to support obsolescence? So this is something that you get together with engineering and you plan for that, what's acceptable, etc., right? It's tough. It is tough, yes. And a lot of this strategy has to do with getting your first MVP out the door just to see if you're going to get traction. And then maybe for version 2 or when you're actually thinking about reducing costs, reducing footprint, that's when you start thinking about that lifespan, right? Also depends on the industry. For example, if you're in energy, I come from energy, so contracts are about 10 years. So you got to make sure that your product at least lasts 10 years and have a plan with that. So there's some guidelines there, but yeah, that's advanced stuff. Great question, though. Thank you.
I'm curious why you put data before business. Is that an IoT specific thing? In general, I would think that you would want to talk about your business model. How would you monetize it before you actually get into the details of what the data would be?
Yeah, that's an excellent question. And it's not an IoT thing. This is just more my philosophy on how to approach it. Because a lot of the value of IoT is in the data that you collect, it's all about what are you going to do with the data that you collect, why you're collecting it, then that plays big into the monetization discussions, because monetization of your data is going to be one of the big parameters. And so that's why I treat it here first, so that we can use it as an input in the business decision area.
So this is stack prioritized?
It is, top to bottom, yes.
Oh.
Yes.
I thought it was irrelevant.
No. It goes in that flow. And that's the idea, because once you go through all the sections, the idea is you iterate. Because the decisions that you make at each area are going to affect the decisions that you make in subsequent areas. For example, let's say that you decide that the best experience for your product is to have, goggles for virtual reality, and that, based on your user research, that's the best possible experience. Well, you might realize here that you need astronomical amount of data to do that, and when you go into your business model, you would have to charge so much to provide that solution that you price yourself out of the market. Okay, so that won't work. And so once you iterate a couple of times and you get to what I call a steady state, that's when you achieve a solid product strategy. Because now all the different areas are consistent with each other. Your UX strategy is consistent with your data strategy, with your business model, with the technology approach. And now you can say, okay, here's a strategy for launching the first MVP, and we can run with it, right? And of course, it's always evolving, right? But that's why I put it in order. Because I've noticed that I've tried it many different times, different ways, and I've noticed that the decisions kind of cascade by itself. So for example, by the time you get to technology and you have these other parameters, that makes it a lot easier to make these decisions, right? So, but again, this is continuously evolving. So before we go into questions, so in summary, I believe IoT offers a huge opportunity for companies and for us product managers in our careers. And it's not only an opportunity, but it's also a risk of obsolescence. If we don't jump into this trend, realize how difficult it is to get the skills, and grow as a profession in that way, we're going to be left behind. So there's a window of opportunity here that I'm advocating. IoT is complex. Not going to sugarcoat it, right? There's a lot of moving parts. It's very complicated. But it's really exciting. There's a lot of very, very interesting, powerful things we can do with this technology. And then the IoT Decision Framework helps you as a step-by-step, a structured way to think about the problem so that you can actually have the discussions with your customers. Another way that I've used the framework with companies is just to have a common language that everybody in the room can point to the same thing and can have, oh, this is what we're talking about. Oh, now we're talking about this piece. And that alone, as a product leader, to be able to guide those conversations and get the consensus of the teams, that in itself is huge. So with that, just want to thank you so much. Let's go over questions. There's a lot of information on my site, my quick start guide, and I also have a bootcamp coming next week at Stanford. So if you're interested in going deeper, check it out on my site as well. So with that, any questions? Any more questions?
As a product manager, you generally get deviated because there are so many things to tackle during the process. What is the least interesting thing in IoT, you think, which can really bother a product manager?
Oof, I don't know if there's a one. I think it's a personal preference, to be honest. I personally like strategy a lot. So to me, be able to work with executives to define a strategy of a product it's my thing. When we move to execution and have to do the minutia of that's to me, less interesting. And, usually I work with my team, so my team can handle that part. But I guess everybody's different, right? And one of the things that I point out with the framework is that you have these decision areas. They also map to skills of people. You will have PMs that are more technical oriented, security oriented, UX oriented, data oriented, so they will find more interest in that. I believe we need to be well-rounded in all of these things, so we need to understand all the pieces and be expert in one crossing, right? Like one technology stack area and one, so for example, you gotta be an expert in cloud UX, and that's your thing. And you understand the rest, but that's where you're super solid, right? And then you grow from there. Yes.
I'm interested in learning more about how the companies are taking this framework when you roll it out to them, when you throw it at them. Because as a PM, when I looked at that, I kind of thought, all right, I'm always starting with the user, and that's the cloud applications part, and that's kind of at the end. So when you take companies through it, do you say, let's think about the hardware first that you've got and build on that, or do you look at the cloud applications and work backwards?
That's a great question. So how do you, for the users, how do you define like the order in which you attack them? A lot of companies have different preferences. I personally like to start at the hardware and then move up to the cloud. And oftentimes in IoT, there's way more users. So hardware itself might have its own users, like the maintenance folks and the technicians. So that's going to be a whole world, right? And then the cloud platform itself is going to have, if you have open APIs, your users are third-party developers, and that's a whole spectrum, right? So I think it's a matter of what I do is I work with companies to set the baseline so that everybody understands the process, and then we start working through it step by step. And sometimes the product managers, like I check with them 6 months later or 3 months later, and they've modified my framework, they've added pieces and moved things around, whatever it takes in order for them to push it through the culture of their company, right? But it's a starting point. Does that answer the question? More or less? Yeah, okay. Thank you. Yes?
So following up on your advice to the product manager to follow one area of the technology stack, your expertise like hardware, software, and data or technology. If you're to advise the organization, the internal organization, if you talk to utility or healthcare client, for example, what expertise would you recommend that they have in-house? Because not everyone has hardware engineers,
right?
Or people who have that background, or cloud and people that's more common. What would you advise?
Yeah, that's a great question. So what expertise would I advise for people to have in-house? The way I think about it is, what is the core expertise of the company in terms of monetizable IP? Like, where is that? Are you an expert in hardware because you have patents and you can go there? Then you should keep that for sure in-house. If the front end is something that is less interesting to you, then that's something you can do. But something that is your core IP, that is patentable, that you can actually be acquired for, that's what you should keep in-house. And by keeping in-house means investing in tools, in training, in growing the teams, etc. Now, there are things that just make it really hard to be in-house. For example, some companies want to build their own cloud platforms, their own data centers. Oh, that's kind of hard to justify, right? It's kind of hard to justify. But again, if they think that that's their core expertise, okay. I advise against it, but yes. Yes?
For the various, I would say silos, the various sections of the tech stack that you outlined, in some cases, the product or the team will be complex enough that that's obviously not going to fall under one product manager. Those tech stacks, or the portion of that stack, obviously would have different cycles per se in terms of how they can release.
Yes.
How have you seen those interplay? What's the successful recipe you've seen for like a hardware division interacting with a cloud application, where a cloud application can rev every week or every day, or the hardware is going to rev once, maybe once.
3 months. Yes.
How have you seen that interact, and what are the successful recipes you've seen?
Yeah, excellent question. So if I understand the question, how are the groups organized and how does the life cycle of each one is managed so that you can actually have interactions but still a working product, right?
Sure, yeah, you might have a PM on the hardware team and you might be a PM.
Yeah. Exactly. So the first thing I would say is that IoT is still in its infancy, and we're all still trying to figure out. So I've seen a lot of different models, but whoever tells you that they have solved it, they'll run the other direction, right? Because we're still trying to figure out. I'm fortunate to have these discussions with like some of the top companies, and we're all trying to figure it out. Some of the models that I've seen work is when you have a division of labor so that each PM can focus on their expertise. So you have ideally a PM for hardware, a PM for embedded, a PM for communications, etc. Right? Usually, if the company is big enough, at the cloud levels, usually they branch, and you have 2 or 3 PMs per cloud, which is cloud APIs, cloud applications per vertical, those kind of things, right? The challenge is how do all those teams work together, communicate together, and what I've seen is that the PM team as a whole needs a common vision, needs a common strategy that everybody can communicate, and then they need to understand the interfaces between the layers so that the embedded team could work as long as they are coding to the interfaces above and below, then they can make progress for whatever the other pieces are ready. And then there needs to be a strong layer of integration testing before it goes out the door, right? So all the teams need to be moving autonomous at their pace, but you have to have a way for putting it all together at some point in some cadence, right? And that's why, going back to my beginning of the presentation, that's why this is so hard, right? It's a lot of different pieces, hardware, software. Each one has its own process, its own timing, its own costs, its own. It's hard. It's hard. But yeah, so it's not a definitive answer. It's a state of the industry answer. Thank you.
Maybe take a different spin on the question. So I want to ask more about the IoT industry in the immediate future. At the beginning of the slide, you said 5 to 10 years. Okay, that's the number of devices. 5 to 10 years sounds a very long time. And also, the word IoT itself was coined maybe 20, 30 years ago. And every year, people are saying, "Oh, this is going to be a big year for IoT, big year for IoT," but I don't know if that's happening. Do you see, like, from your interaction with industry, the big companies, and where do you see the breaking point? Do you see any breaking point in the next 6 months, 1 year, or something?
I do, because it's becoming a lot more mainstream. And like I said at the beginning of the presentation, I've been doing IoT for almost 20 years, but we used to call it M2M, we used to call it industrial automation, we used to call it all these different things. It's the same idea. And I bet you that, maybe a year and a half from now, I'm going to have to rename my course to the buzzword of the day. But it's all the same idea, right? It's this hardware devices connected through the internet that helps us move forward. Right now, we're at a boom because we're seeing that hardware and sensors are cheaper than ever, smaller than ever, and faster to produce and integrate than ever. Software performance in terms of microprocessors and storage is through the roof, and it's growing, right? Artificial intelligence and some of those things are taking big leaps. Networking, it's well established, it's way faster in bandwidth, it's way cheaper. So there's the capability to build these solutions now versus what I was building 20 years ago is through the roof, right? So that's where I see that now we're starting to see that traction. And we might not see a lot of traction in terms of the things that we hear in the media every day. Smart home, those kind of things, they're trying to taking off, but the value proposition is less. If you look at automotive, manufacturing, energy, they're really taking off because now the technology is really impacting the problems that they've always had, but now you're able to do it at a cost that is reasonable, right? And the ROI is there. Right? So I will see that in the next 2-3 years. We're going to continue to see that more and more and more. And I keep track of, for example, job openings that mention IoT, and they have been going up every year, right? So I don't know that there's a tipping point, but it's not a trend that is going to go away per se, because it's just the state of the technology, right?
I would argue that that it's going to actually disappear. So we don't talk about ICs, integrated circuits anymore, but they are in everything in our everyday life. So as it disappears, just like any common technology, then it's ubiquitous. And so it no longer is IoT, it's just part of the landscape of building stuff.
That's an excellent answer, and I look forward to that day. The example that I use sometimes to piggyback on yours is mobile, right? 10 years ago, we were trying to scramble on how to do mobile applications. Today, if you do cloud software, it has a mobile component, and we don't even talk about it. You expect it, right? So that connectivity between hardware and the rest of the world, I think it's going to get to that point. And yeah, the term is going to go away from a hype perspective, but it's just going to become table stakes. Yeah, I agree with you. Any other questions? Okay. If not, then thank you so much for your time, and I'll be around if you want to chat and ask more questions. Thank you so much.